Hi, everyone. Nice
Hello.
to see some of you again for the second night in a row. That's like an extra yummy juiciness in my week. Tonight we have our 5th Global Passive House Happy Hour of 2021 and show number 46. Thanks for joining us. I am Prudence Ferreira, senior member of the Carbon Neutral Design Group at BR+A Consulting Engineers, and I lead their Passive House team. And I've been doing Passive House consulting for over a decade and focused primarily on the big projects and streamlining and standardizing critical path workflows for those. My co-host Monty Paulson is taking some time off still. We miss you, Monty. If you're listening in, come back to us. But even without Monty, we welcome everyone. We're very inclusive here. So whether you're a homeowner or a professional in the building industry, a teacher or a student, if you're just curious and learning, or you're an expert and still learning about building science, passive house, zero energy, zero carbon, electrification, and retrofitting our built environment to reduce GHG emissions, you are in the right place. If you didn't know, February, and that's with the PH, is retrofit month at the Accelerator. So you're going to be getting lots of great content this month about how to restore and give new life to our legacy buildings. And for those of you who missed the construction tech last night, we had a fantastic conversation about Passive House and sustainability renaissance to help support jobs and social equity in Detroit. And that conversation was started by one of our new community members, Ingrid Green. And man, it had me on fire all day. So in honor of all of us piping up and using our voices to share our visions, I'd like to invite all of you to unmute yourselves. And let's have a toast to big visions and Passive House as a force for social equity.
Everybody,
Cheers.
All right.
Salud.
All right. So we've got another great show for you tonight. We're focusing on a single family retrofit in Maine. We're going to hear from Jesper Kruse. But first, over to Zach to introduce our video for this week.
Yeah, thank you, Prudence. And before I do, I just want to give a quick shout out. We're doing a new thing where we have a sponsor of the week, and the sponsor of the week this week is Partel. So I wanted to thank Partel for supporting all the work that we're doing and all the programs that we're doing this week. So on to the video, we're going to be sharing a video from Sean Taylor of Team Green Architects. She's based in New Zealand, and she's actually the focus of the Passive House podcast episode next week. There's a great interview between co-host Matthew Cutler-Welsh and Sean Taylor that we'll be featuring next week. And so as a little teaser, I wanted to share a little video that Sean put together for the Passive House Open Days that International Passive House Association put together last summer. So it features Sean's house, and it's a small project that's located in New Zealand's mountains. So the Misty Mountains, if you're a Lord of the Rings fan. And the bottom floor of this house is their home, and the top floor was designed as a separate flat. So also remember that this is a project that's in the Southern Hemisphere. So when Sean's speaking about northern exposure, that's like Southern exposure for those of us in the Northern Hemisphere. I've selected 3 segments of the video to show you tonight, but please check out the full video. I'll share it in chat now so that you can see the whole thing. And with that, let me navigate over to the video. Great little project tour, and please, it's a really interesting conversation with Sean on the podcast, so please check that out. All right, we're going to go into breakout rooms now for 5 minutes, so please try to do your best to get around to everybody and do rapid fire introductions. And let's see here. All right, I think everybody is returning from the small breakout rooms, and can people see this shared screen here that says Passive House Week in Preview?
Mm-hmm.
Yeah, okay, great. So every week we publish one of these articles that previews what's coming up in the coming week. So and I do my announcements from this. Yesterday, we had a great session with Prudence at Construction Tech. Today, we're treated with a presentation by Jesper Kruse. Our Passive House podcast episode is an interview between Matthew Cutler Welsh and Anton Dobrevsky, who is the founder of Passive House School. Great conversation, interesting roots from his upbringing in Bulgaria by a Passive House pioneer father, and now his dive into sharing Passive House knowledge. Thank you to Partel for being a sponsor of the week. And we have our retrofit summit on February 15th. So Prudence mentioned that for us, February is retrofit month. And Mary James has put together another great program. I'll share a link to registration in chat, but this will feature Pembina Institute, talking about Reframed Initiative, information about Retrofit New York, Realize, Recover Initiative, Triple Decker Challenge with Mass CEC, from Mass CEC, as well as the 50 Houses Research Initiative by Passive House Maine. So it's going to be really cool. Please join us. And then lots of great socials going on, including an appearance by Chris Ballard of Passive House Canada at Building Science Fridays that is hosted by co-hosted by Mark Willey, who is also a co-host of the Passive House Accelerator Construction Tech Tuesdays. And then tons of educational resources. Everybody's in full swing with classes. So please check all this out. And no time like the present to take advantage of these virtual courses. Thank you. Prudence, take it away, please.
Yes. All right. So tonight, our featured guest is Jesper Kruse. And Jesper has a really interesting story. I did a little bit of research to prepare, and I was very delighted at what I found. So Jesper was born in a Danish fishing village that has since become the vineyard of Denmark. But in 1987, he escaped to Alaska. And from there, he took an adventure down to the lower 48 before returning to Denmark. But thanks to the influence of sled dogs, yay, he came back to the US, to Maine, and ended up volunteering for Outward Bound. But soon he was off traveling again all around the world for another 5 years before doing another stint of volunteering for Outward Bound in 1992, where he met his future wife, Martha, now present wife of 22 years plus. And it was their love that eventually brought him back to the US. And they got married, and they drank Coors Light while they were doing the legal paperwork. Fast forward through building a house, buying land in Greenwood, Maine, and having a family to 2008 when he started Maine Passive House. He was originally a guy with a truck, and now he manages a crew of more than 10 based out of Bethel, Maine. Being the adventurous and dedicated guy that he is, of course, it was only a matter of time before he had to embark on the retrofit of his own house. And tonight he's going to share with us the nitty gritty of his multi-year retrofit and share his tips for passive house retrofits in cold climates. Thank you so much for joining us, Jesper.
Thank you so much for having me. So let me just get this shared with you guys. All right, hopefully this shows up now for everybody with just my slides and not all kinds of other stuff on my screen. Okay, cool. So thanks for having me. And my name is Jesper Kruse. My company is Maine Passive House. And what you're seeing here is my own house that's in the middle of the retrofit that we did. Started with us having some wooden windows. So we built the house 20 years ago. And after 15 years, the wooden windows that we bought were just toast. So we had to change the windows, and that kind of that was what kind of catapulted me into this retrofit where we did one side a year until we finally got sick and tired of it and did the last 2 sides in 1 year. I can just say that I am really happy we did it. The house is extremely comfortable. You can tell that the air in the house is just, the air quality is much better than it used to be. The house is really resilient. It gets below 0 degrees Fahrenheit here. And, you know, we can leave the house unheated and come home and the temperature won't drop. It will never freeze inside. I can say that for a fact. So I'll talk a little bit about money at the end, but jump right into it here. So what we had originally was, you can see we had it's a slab on grade, frost walls with a slab. So we have our frost walls. We have a concrete slab with 2 inches of XPS foam below, so that's existing. Have a 2x6 wall, original, and then a set of trusses up on top. So what we did is we laid out an airtight membrane, added a 9.5-inch Larsen truss, a TJI, to the outside, installed triple pane windows and mechanical ventilation systems, added more cellulose up in the ceiling, and that's kind of like the quick breakdown. So the foundation, we took our airtight membrane, which is a DA membrane from Proclima. We attached that to the foundation, and then we added 10 inches of EPS foam down to the bottom of the footers. Here it is when it's all done. We wrapped some tar paper around it to try and keep the critters out. And then that's really all that happens to the foundation. Here's a little detail. Not much to say there. Put it in so if people are going back later to see the presentation, I want to check out the details, you can kind of spend a little more time on it there. So here you can see our the airtight membrane. All the seams are taped. We have our window box, have a little piece of Mento that we wrap down below here. Mento plus membrane that goes under the trusses, so that can get wrapped up. Blocking around the windows, you can see our Lunas units, which are the ventilation units, kind of sticking out through the wall there. And here's the detail again. With the air barrier really being the important part. We like to have it in that 1/3 from the inside of the house, ideally. And then we have the Mento Plus that goes on the outside of that. You can see the wire penetration sealed up here with some neat little things. And here's the project with a rain screen. So we're having a rain screen in here right behind the cladding, so that can vent all the way up. That eventually connects all the way up to the roof. And that's how the whole outside of the building kind of gets vented. Not much more to say there. The roof, the biggest hurdle and challenge. So what you're seeing here is the DA membrane that we brought up the wall, and then we draped it out over the TJI or Larsen trusses, so that the walls are kind of sealed onto themselves. And then from there, the Mento then gets wrapped up over the roof, so we can kind of wrap the whole house in like a neat little package, rather than having the rafter tails sticking out, and having to tape around those to make it all airtight. Then we cut out about 3 feet of plywood up along the ridge, being so that this used to be a vented attic space, and now we're sealing the whole attic up. So the thinking here is that the Mento plus membrane that has a high perm rating will allow moisture to get out through these gaps here, rather than having to try to get through the plywood, which doesn't have that high of a perm rating. Bolted some new rafter tails on here, vented the whole roof so that there's airspace going up through there. This is actually just spaced up, so there's still air going through here. So it's coming up along our walls, and then it goes all the way up to the roof, and it vents out up in the ridge. And put a roof on, and we had my roofing guy bent up some special, very wide drip edge panels so that we could use the existing roofing panels. Again, since there's still life left in those, so rather than throwing them out, we found a way to reuse them. The attic, definitely the biggest challenge of the whole project. Used to be ventilated, and now the thought is, what happens if we have moisture that migrates from the inside of the house and gets into the attic? Does it get out through that Mento membrane up in the top? I really like to try and keep the moisture from getting in there in the first place. So We had 16 inches of loose fill cellulose up in the attic to start with, so it's a bit of a challenge, but the snow shovels, we kind of cleared it out of the way, and then we took Intello membrane, another product from Proclima, and we pre-cut the membrane so that it would fit around these cross braces in the trusses, brought it up there, stapled it down, and then very carefully taped around, taped that to the cross braces, taped up in here where there are like little gaps and stuff. And it was tedious, but I'm really happy that I did it. I feel like that was a critical part of the whole project. And obviously at some point it'd be nice to climb up in that attic and see what's going on, but I don't have easy access, so I'll let you guys know when I make it up there. So Anna, Matt, and I here, we're all excited, getting ready to go up there and kill this project. And we did it in the beginning of May. It's probably like not even 70 degrees outside, I think like 20 degrees centigrade. And it was probably like 120, like 55 degrees Celsius up in that attic. It was very, very hard work, not a lot of fun, but we got it done. And we did one side, what we learned from doing one side of the wall, and when we came over to the other side, what we realized is if we just cut the plywood off the bottom of the roof, then it'd be a lot easier to attach this Intello membrane from a set of staging and just work on it right there, getting all these connections taped up really well. We did put down some EPS foam along these edges here, just so that we had something solid that we could push down on as we were working the tape in the connection from the truss to the tape. And then the ceiling around the chimney here, just have two pieces of metal that slide in from either side, and where they overlap, we caulk it, and then put some high temperature caulking around the chimney, which is what Anna is doing in this photo here. On the inside, we added a 2-inch by 2-inch equilateral triangle piece of EPS foam, seeing that the trusses where the walls and the walls and the roof are meeting, there's only like 3.5 inches of insulation. So we wanted to do something to kind of alleviate that thermal bridge there. And it was a balance between adding insulation and eliminating the thermal bridge, and still trying to keep that outside connection somewhat warm so that we don't get condensation out there. So you can see in this thermal image camera photo up here that, you know, it is a little bit colder right in that connection, but it's not horribly bad. So then we just put a piece of painted wood over it, so kind of blends in fairly decent. Decks and porches. For the new deck that we added onto the house, we just bolted on these metal straps that we had fabricated. We bolted those onto the rim of the deck before we installed it, and then we just bolted those straps into the TJI, or the Larsen truss. So that whole deck here is just hanging right off the building. And is it strong enough? We get a lot of snow up here, and you know, several feet sometimes, and that all slides off the second story and comes down and lands on this deck. And the deck is still hanging on the existing porch that we had. And you guys are all welcome to hire me for your drafting projects here. We removed some decking boards in here, and then we docked down as far as we could get. This deck is very close to the grade, so it wasn't easy work, but we docked down as far as we felt like we could to insulate the exposed part of the foundation, and then some. And then we added some vertical foam insulation. It's actually much closer to the grade here. So, and then we insulated in between the rims, and what it looks like is this. So you have the insulation down below, the vertical insulation that's kind of preventing the frost from creeping into the ground underneath there. Some wood that's holding it in place, a little bit of spray foam to make it nice and tight. And what you're looking at here is the rafters coming into the building, the collar ties. So the collar ties, we cut them back so that we could run our airtight membrane right up behind that, and then we taped that to the rim, taped it up above to the rim. We could also get our weather-resistant barrier, our Mental Plus, in behind this, behind the collar ties. So that's as far as I was willing to go in terms of demolishing. You know, ideally we would have detached the whole porch, but I just wasn't willing to go that far. So got to make some compromises when you do a retrofit, for sure. Mechanical systems. We're using Lunas units for ventilation, and the benefit obviously to these are that it's all within the one unit, right? There's no duct work required, so obviously makes it much more attractive when you're doing a retrofit and you're not tearing the entire inside of your house apart. So just to make it clear, the inside of the house, we didn't really change anything to that. For heat, we have a single 12,000 BTU air source heat pump that's mounted kind of between the first and the second story. And that will easily warm the whole house. Doesn't really cool the upstairs. I don't really care about air conditioning, but we tried, and it will cool the downstairs, but not the upstairs. Then we have a wood stove with a dedicated air supply coming in through the back that we're very happy with. It works really well. I know if we were trying to get this project certified through the Passive House Institute, there would probably be all kinds of loops that we would have to jump through with the Passive House Institute to, you know, the concern is that, like, you have a wood stove in a passive house, you have a ventilation system, do you potentially get like a negative pressure inside the house? Could you potentially like be pulling the smoke out of the wood stove and into the living space and killing everybody? Definitely a legit concern, I think, but I haven't had any issues with it. For the hot water, I wanted to try and put in a heat pump water heater, thinking that the heat pump part, so, you know, you can turn them to electric. So I was thinking, well, we'll turn it to electric in the winter, and then in the summer, when it's warm in the house, we can run the heat pump, and it will cool the house. It will dehumidify the house, and it definitely does, to the point where it's just like uncomfortable. So even on the hottest days of the year, the bathroom that is next to our utility room is still like uncomfortably cold. So I would definitely not recommend getting hot water that way. I would probably just, if I was doing it over again, I would just get a really well insulated electric hot water tank. Materials, just a quick word about that. You know, we used membranes and dense packed cellulose primarily for the air tightness and for the insulation. And from what I've heard, is, you know, if you go out and you build a passive house and you're using like, you know, closed cell spray foam or a bunch of XPS foam, you could potentially build a passive house that releases more carbon over its life compared to like a code-built house built with better products. So if you are concerned about climate change, you should definitely pay attention to what materials you're using. And I think the money part, I think, is the last little bit about it. We spent almost $160,000 in this project. The house is about 2,000 square feet, so it comes out to $81 a square foot. We had to replace the windows, and the siding that we installed originally, we kind of screwed that up. So I could argue that that has to be replaced as well. So I don't know if the cost of the new windows, the installation, and the siding would come to, maybe, if you're in a good mood, you could say like half of the total cost. So, you know, it's not an inexpensive endeavor to retrofit your house to a passive house, I would say. And this, of course, is, you know, my company and my employees from my company did the work, but this is like kind of calculated as if I were paying full price for it. So, you know, if you're doing the work yourself, you can obviously do it for a lot less money. And that's it. And here's the house now that it's all done, and we're happy with it. So that's my thing.
So Jesper, I was
Thank
just
you.
getting the.
Thank you so much, Jesper, for sharing
Yeah.
that all with us.
Let me just ask a quick, do you want me to stop sharing this or on the screen? Does that matter?
Jesper, I would say just leave it open for a second because there's a few people that wanted to go back and look at the rafter details. So if you want to go back, and maybe what I'll do is, I think, was it Tom that had it or was it Jeff? So I think, sorry, just go back.
Detail right here.
Yeah. So if you leave it right there and just want to explain that, because I think Susan and Jeff had questions about it. So just kind of, again, describe what's going on with how those are attached. And
oh, got it. No, I see it.
I know we made Jesper kind of rush through these things, and so he skipped, maybe 5 seconds too fast on this slide. But again, you want to just go through how you did that detail?
Yeah, so we just took, these are just 2x4s, and we we cut these blocks here with the bevel of the roof. We screwed them to the 2x4s. So we prefabbed all those on the ground, and we brought them up on the roof. And then we just bolted them through the 2x4 into the existing rafters, and they're just hanging off here. And, then eventually we run a string here, cut all those back, and put a sub fascia on it. But super rugged, definitely no concerns there in terms of it not being strong enough.
So it's two pieces of wood that form a T, right?
Exactly.
Right.
That's correct.
And so
yeah.
So is it 2x4 to a 2x4 or 2x4 to a 2x6 or
2x4 to a 2x4?
Oh wow, okay.
And then I think the key to it is that the heel of that lower 2x4 is tight against the old rafter, right? So as that roof is trying to sack down, it can't, that connection between the heel and the old rafter is tight, and it keeps it from being able to sag. If that was just kind of like hanging out in midair, I would be much more concerned about it sagging. And then when we're building the rain screen, we're making sure too that the rain screen comes up and has a little bevel, right? So it just gives that little added extra support to help hold this up.
And what is the projection of the overhang?
16 inches.
Thank you.
Yeah,
I tell you, I have a house in northern Vermont that I'm thinking of doing something like this too. So this is just so perfect.
Well, I'm glad you like it.
Jeff, I think there's a lot of people, I mean, even the detail of how you kept the roofing material and you just added that extra, whatever, 16 or 24 inches of new metal to keep the old roof. I mean, that's just, again, great way of dealing with resources.
Yeah, it just seemed like, the roof was still in decent shape. So why throw it out and buy a brand new roof?
Yeah. Okay, we'll keep going with questions. Thanks for that, Jeff. And I think that was Susan's as well. So going back up to Tom Bissett Dilly, you were actually first in the queue. I don't think we answered your question. So, Tom, are you there?
Yep, just had to unmute.
No problem.
I didn't see what the walls were filled with. Was there a picture of cellulose and I missed it, or is it EPS outside?
It's all cellulose. So
great. And the sheathing is on the exterior is did you sheath it with a fiberboard or just
the
the
sheathing?
The Mento?
Just the Mento, and then it's 1x3 strapping that's nailed into each Larsen truss or TJI, and then there's just a little skinny piece of strapping that's put in. So that's 2 feet on center, right? That's a TJI, that's a Larsen truss, that's a Larsen truss. In between here, we're just putting like a little thin piece that just keeps the membrane from bulging right out, right? Because as it gets filled with dense packed cellulose, it will otherwise bulge right out and actually rest against the sheathing. So it just
Yeah,
kind of
did you-
keeps it all in there.
Did you compartmentalize it vertically? It's pretty tall, huh?
Yeah, no, it runs all 16 feet. So what my insulator does is you can see, I think, you can just see the tape up here from where we cut into the membrane, right? And then they dense pack from the bottom up. And then they go around, they'll end up cutting smaller holes here and there to make sure that they got it all dense packed everywhere.
Wow.
And let me just say one super important thing if you're doing this kind of detail here is to make sure that you come up with a really good detail of keeping critters from getting into this assembly here, right? So either having like insect screen or like core event or something that's meticulously installed, because we did have one little piece missing, and I hear this little mouse run around in there. Luckily, we have that vertical siding, so it's easy to pull a piece off and put a little mouse poison in there. And then I found a hole in the spring after the snow was gone, but watch out for that.
Excellent. And I mean, Tom, and most people in some colder climates, they're going to put maybe a small, like a 22 mil or thin wood fiberboard on the outside just to stop some of those thermal bridges through the eye joist. But Jesper's done a great job in the detail there, so it's pretty good. So yeah, moving on. Tom, you're good with that answer?
Sure am. Thanks a lot, Jesper. This is a great project.
So I think Tom Phillips, we answered your question because you were looking for some thermal imaging of the details, and you spoke a little too soon. So I think we took care of you there. But Tom, did you have any other questions? I did see some chatter with you, and a couple other points. Tom Phillips, do you have any other questions?
Yeah, I was trying to think about changes in wood and energy use, and obviously he probably hasn't gone through a winter yet with a new stove, but just be curious to see if he's going to track that.
Yeah, I mean, we actually have lived last winter, I guess was my first full winter, but I actually haven't looked at the total energy consumption and added it up. I probably would have been smart of me to do that ahead of tonight, but so just kind of right off the cuff, I could say we're probably burning say like maybe half a quart of wood and maybe 3/4. And then my energy bill is probably like $150 a month on the coldest, like December, January, February.
Wow.
And then, drops down to like $50 in the summer months, something like that.
Thanks.
Thanks, Jesper. Yeah, because Tom's question was, how many cords of wood did you need the winter, past versus future? So it's always nice when you can measure it in, quantity of wood.
Definitely a lot less than we used to, that's for sure. We probably used to burn like 2 or 3 quarts of wood to heat the house, with a backup gas boiler.
All right. So moving from Tom, Barbara in Oz.
Hi, thanks. Really interesting project. I'm starting to plan my own passive house, knock down my brick house, put up a passive house, hopefully using low carbon stuff. So that little chart you had was really useful for me. It's going to depend on what I can afford. The heat pump, hot water. Did you had that indoors? Is it better to put a heat pump indoors than outdoors?
Well, I'm guessing does it ever freeze where you live in Australia?
Yeah, sometimes it will get below, it'll get to Celsius. It'll get to -1, -8 at the most in the wintertime. Not for long periods, but freezing.
Yeah, so I think the heat pump water heater. I mean, I wouldn't want to have it outside if if you have frost. I don't know if maybe it's, maybe you could build some simple enclosure or something like that and have something on a thermostat that would kick on, if in case on cold nights, and then just take advantage of the heat in the air otherwise. But if you have a basement, you know, where
No.
you don't care, no.
basement.
I would be concerned about having it in a living space. You know, it's obviously a very different climate where you live. I'm guessing compared to where I live, you know, we have like, I mean, you know, I got like 3 feet of snow out in the yard right now. So
We'd
it,
love
it
3
just,
feet of snow. It's getting up to about 30 Celsius today, so.
yeah. So I'm just really surprised by how much heat that hot water heater manages to take out of the air.
Yeah. And then what do you do to prevent the development of Legionella? Do you have a UV thing to kill bacteria or?
For the water?
Yeah.
Well, it just gets pumped from my well, so I don't think that's even an issue, you know, just because it's constantly rotating through the tank.
So what's the temperature you keep it at? The tank?
I forget what it's set at, like 120, you know,
Oh,
like
okay. Oh, pretty hot.
60 degrees Celsius or something like that.
Yeah.
Enough to keep, you know, the formation of bacteria in it.
Okay. Thanks. Thanks a lot.
Yeah, absolutely.
Thanks, Barbara. All right, Susan, you had a couple of comments or questions. Do you recall which ones you wanted to ask today?
Oh, I can certainly ask. And then, so there I was just sort of writing random things in the chat as I want to do. And so the Sanden, Scott Kennedy, you should probably speak up at about this time.
I got him in the queue, don't worry.
Okay, all right. So I'll ask my other question. Thanks, Jesper. I've actually looked at these Lunos units before. They're very interesting. Can you tell me a little more? Like, are they're actually heating the fresh air, very small quantities? And then also, I was wondering, how many did you put in these Lunos things?
So we have a couple of different. There's the E2, right, where you have 2 of these units working together, and that's what you can see right here. So they're connected. So they run for 70 seconds. They suck the air from the outside through here, through this very heavy ceramic honeycomb. So so one unit will be sucking in the air. They're connected together, right? And then the other one will be exhausting it. So as the other unit is exhausting it and it's blowing the hot air out through the honeycomb, it's heating up the honeycomb. And then when it switches back over, it's sucking the air in through the honeycomb. And then the mass of the honeycomb is heating the air as it comes in. So I'm really impressed by the heat recovery of these units. I was afraid that you would be able to tell that the air coming into the house would be colder, but that's not an issue at all. So we have 2 sets of the E2. So we have 3 of the units are mounted in the bedrooms. So 1 in each bedroom and then 1 in the living room. And then in our bathrooms and kitchen areas, we have the E-Go units, which are basically split down the middle, and they have 2 fans in them so that they can do, you know, they basically do the same thing that the 2 units do, but they do it all in 1 unit. So that, you know, because you don't really want to suck the air from your bathroom through the entire house, right? So the downside to these units, I would say, is that the fan is right in the wall in each room, so you can hear them. I mean, I'm sitting with my headset on right now, and I can still hear the unit that's running in the room where I'm at now. I could turn it down, and I wouldn't hear it, or, you know, lower it. It's running at high right now, but that would be the downside, I'd say. It's just that it's, but
it says it's, I'm looking at the spec sheet right now for the E-Go. It says 17 decibels to 47 decibels.
Yeah, that sounds about right. So it's like, you know, it'd be like a refrigerator running, maybe when it's running on high. You definitely hear it, but you know, it's not like, you know, I don't really think much about it. You kind of get used to it, and you know, you can always just lower them down. You know what I mean? And normally you would run them at high if you have a lot of people in the house, in which case there'll be conversation going and you won't really notice it. So, but if you're very sensitive to that sort of thing, it might be an issue.
Great. Well, thanks for talking about that. Thank you.
Absolutely.
Thanks, Susan. We've got Kevin Brennan had the big question. Kevin.
Thanks, guys. Nice project. Great presentation. My question was about what was your blower door test result, and then when did you guys do the cellulose insulation, or did you hire a subcontractor, and what insulation machine did they use to dense pack?
So the air tightness was 0.54. So I was really pleased with that. Obviously, I mean, that would be, that would qualify for a newly built passive house. We did hire a cellulose contractor to install it. I'm not sure what he used for a machine. It's blue. And he's been insulating all my homes. So I know people ask, about the I think the key to dense packing, I think, is obviously just to make sure that it really is dense packed right to the 4 pounds per square foot or whatever the recommendation is. So I can tell from, the house was originally insulated with cellulose, and while we were doing the retrofit, I got to see what was going on inside those walls, and never did I see any kind of settling anywhere. So I don't know if that answers your question.
It more than answers the question. Most likely it was a Crendel, and sounds like you have a great cellulose installer.
He's very good. Yeah, I'm very pleased with him.
It's all about the guy with the nozzle in his hand, making sure the entire wall is filled. So
yeah, so I know, they do blow it with a 4-inch hose when they're like kind of like just getting the bulk of it in there, right? And then they end up coming back with like maybe like a 2-inch hose afterwards to really pack it.
So they do a 2-pass method. Nice. That's
yeah.
Cool. Great project. Thank you.
Something about quality assurance, little details. Thanks, Kevin. Tom Phillips, we had you, so we're going to go to Darcy Dunal. Darcy. I don't see Darcy there.
Sorry, still learning about the unmute button.
Oh, good.
I was going to ask you about the blower door test, but that's been answered. But we just put a Morso wood stove in a client's house, and it's fantastic. Like, it's super energy efficient compared to its old Vermont castings. Did you do anything to the air intake, like any kind of damper for when it's not in use? Because the one that we put in is a bit of a run to the stove from the outside wall.
So we placed the stove directly against the outside wall. We relocated. It used to be in the middle of the house. We moved it to the outside, so it just goes straight. There's probably 3 or 4 inches of uninsulated duct that goes in there. So I've been thinking a lot about that. You want a damper that cuts it down so you don't have draft going through the wood stove when it's not in use. And what I decided is that, if you're closing the damper on the wood stove down to low when it's not in use, isn't that kind of like cutting down on draft through the building? That was, so to answer your question, no, it's just, there's a little dry vent on the outside, and, it doesn't have a damper on it because that would be, it probably, anyway, no damper, just like a little insect screen in there so that you can't have critters climbing through. But, I don't see any kind of frost on my wood stove. I don't feel it's not colder at the wood stove when it's not in use and it's really cold out. So, and I'm really happy that I do have the wood stove. We lose power I lost power like 3 days in a row last month. So that wood stove was really nice to have.
Great. Yeah. Okay. Thanks a lot.
Thanks, Darcy. Zach, are you ready for a bit of a recap?
Absolutely.
You're
Actually,
on the ball.
the honest answer is no.
I
But
know. You didn't respond to my personal message, so I just checking. I'm stalling. This is me stalling. Hi, everybody. Glad you're enjoying the show. We're going to switch over to Zach in a moment. Just let him play around with the computer there. He's got some technical problems.
Appreciate that. Thank you. That was masterfully done. All right. So yes, absolutely. I'm going to steal the screen here from you, Jesper. This is a great presentation. Thank you. So everything that we do at the Passive House Accelerator is thanks to our sponsors. None of it would be possible without them. So please, please do support these fine companies by including them in your projects. So our founding sponsors are 475 High Performance Building Supply, Baxtingwe Architects, Glavel Foam Glass Gravel, Minotaur, Mitsubishi Electric Train HVAC US, Partel, RDH Building Science, Stocorp, and Zola Windows. Our stakeholder partner is NYSERDA, and our patron sponsors are BR+A, Brennan Insulation and Airtightness, Initech Windows and Doors, and US Engineered Wood T-Stud. I mentioned earlier that our sponsor of the week this week is Partel, so thank you, a special thank you to Partel this week. Next week, our Passive House Accelerator Construction Tech will feature Brandon Weiss of DeVel, which is a prefab company in San Diego, and he'll be presenting about offsite Passive House projects. Don't miss it. And then we will have Amy Faya from Baxtingwe on Wednesday for the Global Passive House Happy Hour, continuing our theme of retrofits for February. And she'll be presenting about this really cool historic firehouse Passive House retrofit during that presentation. And then again, on February 15th, just a reminder, we have our Passive House Retrofit Summit. And I will include, again, registration information in the chat. That's it. Thank you.